Let's begin with our star, and we'll watch this bronze 193 angstrom view twice. It was an awkward, multiple small release event from just right of center. The coronal mass ejection produced is tight, minor to moderate in size, but has an excellent chance of enhancing the solar wind here in the next couple of days. It was mostly the release of small filament components that were connected to a new growing sunspot group. We can watch that area here, and you'll see that sunspot rapidly growing. The reason the eruptive events were so small is that the flaring coming from that grouping remained just in C-class range, just enough to make the push. But interestingly, it is near where the Earth-Sun magnetic connection was found, and it's driving a rise in the high-energy protons at the moment. Still at low levels, but scientifically interesting that such a small event energized the interplanetary magnetic field enough to send those extra particles our way. Let's quickly recall that the auroral energy transfers toward the equator through the ionosphere, helping drive the global effects of space weather, because now we have a fantastic piece on how the electron precipitation can be found much closer to the equator than was previously thought to occur. Again, when the sun delivers, it delivers to the entire planet. In that same vein, the global ionosphere is tied together at all latitudes, even if you just look at the field-aligned currents near the polar region. When modeling is made to match the observations, we again have to think about that electron precipitation, as for about the 8th time in 2 years, they notably suggest inaccuracies in the Joule heating models. So much of the sun's impact on Earth has been previously missed in climate modeling, and sadly, even these newer studies don't seem to be swaying those reporting in the pure climate change community. Eyes closed and fingers in their ears.